Okay, in this part, we're going to look at converting coordinates, either from polar to rectangular or rectangular to polar. When I do these, I like to have an idea of what I'm supposed to get when I finish. So I'm going to take this point right here, 2 7 pi over 6, and I'm going to sketch it out. So I like to do the angle first, 7 pi over 6, and then a radius of 2. So it has a length of 2. So we will be looking for this ordered pair right here as an xy coordinate pair. We're going to do each of these one at a time. So we're going to calculate our x, which is r times the cosine of theta, and then we'll do y, which is r times the sine of theta. R is 2, and our theta is 7 pi over 6. Again, r is 2, theta is 7 pi over 6. And now I'm just going to insert those values. So on this one I have 2 times, now this one is negative, it's in the third quadrant. Cosine of 7 pi over 6 is negative root 3 over 2. So multiplying those two together gives me negative square root of 3. And then this one is 2 times negative 1/2, which gives me negative 1. Therefore, the polar coordinates 2, 7 pi over 6 correspond to a rectangular ordered pair of negative 3, negative 1. There's the ordered pair in a rectangular format, x and y. The next one's not going to take very long. 0, 5 pi over 4. So I turn to 5 pi over 4. So I have 1, 2, 3, 4, and then 5. So I'm halfway down in the third quadrant. But my radius is 0. Don't go anywhere. And you can see right there that your coordinate pair in rectangular form is going to be 0, 0, the origin. And if you didn't realize that, that's okay. You can start out thinking x equals 0 times the cosine of 5 pi over 4, and y is 0 times the sine of 5 pi over 4. And anytime you multiply by 0, you get 0. So there it is, finished out. Now, using our graphing calculators, you want to be looking at the angle menu. You will be calculating the x value and the y value separately, one at a time. So let me see if I can pull up my calculator here. So I'm going to go to second angle, the apps button, and I want to go from this one rectangular or polar into rectangular. Notice we're doing the same point that we had done before. So I'm going to choose number 7. And you see number 7 has P to R, and then there's an X after it right there. That's the one we're after. So I'm going to hit choice 7. Now I need to type in the ordered pair that's in polar that I want to put into rectangular. So I put in 2, hit the comma, and then I'm going to do 7 pi over 6. Now I also made sure before I started this that I was in radian mode. Since my angle is in radians, I need to be in radian mode. And that's all you need to do. Close it off, hit enter. So negative 1.732 is my x value. Let me go ahead and do the y value while I'm at it. So I'm going to do second angle. Now this time I'm looking for the y value, going polar to rectangular, the y value. It's not letting me go down. I'm guessing it's choice 8. Yeah, there it is. Okay, well, I'll just do choice 8. And I'm going to type in exactly the same thing. Do 2, followed by the comma, 7 pi over 6. Close it off. And there's my y value, negative 1. So I go back over here, and this is what I typed into the calculator. I'll just write it in the keystrokes. I went to P to R, polar to rectangular, to get the x value. I typed in 2, 7 pi over 6, and it gave me negative 1.732, which is actually negative square root of 3, like you saw in the example above. And then the y value, we typed in p to r, polar to rectangular, the y value, typed in the information again, and we got negative 1. So there's your ordered pair. Negative 1.732, negative 1. Now this next example is going from rectangular into polar. This is your x, and this is your y. So we're going to use some slightly different buttons on this one. Same menu, and you might have seen them already when we looked at the first time. We're going to be concentrating on choices 5 and 6. I'm going to pick choice 5, which is rectangular to polar radius. So this time we're going to calculate the radius separately from the angle measure, just like we did x and y separately on the other example. So this is going to be 3 square root of 2, close out the square root, comma, and then I've got 3 square root of 2 again, close it up, enter. So my radius is 6. Come back to that and write it down in a minute. Now let's go for the angle measure. So now I'm going with choice 6. I'm getting theta. And I'm going to type that in again. And honestly, I could have just copied and done that again. You know what? I think I might do that. So I'm going to do second entry. And then I'm just going to go back up in there and do second angle and change it to 6 instead, and voila, it's all typed in there nice. And the angle measure is in radians, 0.7853. Now I'm suspecting that that's with the 3 root 2 and 3 root 2, that's looking like an isosceles right triangle to me. So watch what happens. When I take this decimal, I'm going to divide it by pi, and I get 0.25, which means that my angle is pi times a quarter, or pi over 4, which makes perfect sense. It's a 45, 45, 90 triangle. So let's record our results here. So we did the radius, and we got 6, and then we did theta, and we got 0.785. And what I did from there was I suspected that it was a special angle. Not all of them will be. But I did go ahead and take this, and I divided it by pi without rounding it off. And I got 1/4. So that means that my angle theta is pi over 4. And again, if you wanted to check this out, the angle, if you go out 3 root 2 for your x and 3 root 2 for your y, you're going to have your 45, 45, 90 triangle right there. So that's using the calculator. All right, now coordinate conversion rectangular to polar. Also quite simple. Let's look at this first one here, 0, -5. So I'm going to plot that as 0, -5. We need to know exactly where that is. We need an r, and we need a theta. And this one is on an axis, so it's a little simpler than most. Our radius is going to be 5, so we're measuring from the origin. Radius is 5. And our theta, well, we start in our normal spot, and we're going 3/4 of the way around the circle, which means we're at 3 pi over 2. So we could record this as 5, 3 pi over 2. Or if I wanted to use a small angle measure and make it negative, I could go this way, end up that way, but then backtrack and actually go negative. There are several different ways that you could do this, but we could also keep in mind here that we're supposed to be having our theta between 0 and 2 pi. If that's the case, then we don't really want to think about going that direction. We just want to go the opposite of what we did before. We went down, so now we need to go up. We're out there, but we need to go the opposite direction. So this would be the same thing as going a -5 radius, but turning to pi over 2. Okay, then the other thing we could do is, if we're not on the axis, it looks a little different. I go over to 5, and then up to 12, so there's 10, 11, 12. So there's the point that we're looking to convert. What is that point out there? And put these in so we see what's going on. This is 5, this is 12. So our radius is just our magnitude. How far is that point right here from the origin? Well, it's the length of the hypotenuse. So our radius is going to be 5 squared. Radius squared is 5 squared plus 12 squared. And that means r squared is 169. Or you might just recognize the Pythagorean triple. R is 13. Now for the angle, we're going to use the fact that the tangent of theta is y over x. So our y is 12, our x is 5. You're going to calculate your inverse tangent of 12/5. This is a case where it's not a very special radian measure. It comes out to be 1.176, and that's in radians. So there's not much else you can do with that. So our rectangular form transformed into polar is going to be 13, 1.176.